Okay. So what is a function? So the way I like to think of a function, and I've got this picture right here, it's like a working soda machine. Okay. If I walk up to a soda machine, put my dollar, I don't even know how much a soda machine is these days, put my money in and hit the Coca-Cola button, and I might get Coca-Cola and I might get Mountain Dew, that machine is not functioning and I am not happy. It's got to be predictable. When I push the button, I have to get out a predictable thing. Okay. Now, notice there can be 7 buttons that give me Coca-Cola. That's okay, as long as each button has a matching output. Now, even if I had a soda machine, like this one's all Coca-Cola and Diet Coke, even if I have a machine that every button looks different and it still kicks out the same thing, no matter what I push, I get Orange Crush. Okay. Now, even if it doesn't seem to match the button, and I wouldn't be particularly happy, if it's predictable, it's still a function. If walking up to the machine, somebody could stop me and say, no matter what you put in there, you're going to get Orange Crush. It's still functioning. I know what I'm going to get when I push the button, so that makes it a function. Okay. So that's the issue. When I push a button, do I know what I'm going to get, or is it one of 2, 3, 4 things? This idea of what is a function and domain and range are going to be an ongoing theme for the rest of your math careers. They are huge, huge topics. You're always looking at almost everything we look at as a function. Really, domain and range are always a really, really big deal. So that's the type of thing we're looking at. So what is the official definition of a function? There's a million of them. This is not official. It's kind of more casual. If you're looking at the information in the book, I think the book in the first 1.1 section gives 3 or 4 different definitions of a function right there. It's just kind of how it's phrased. So it's really kind of more of a feeling. And then when we're looking at it, is it a graph? Is it mapping? Is it a set of ordered pairs? Is it an equation, as we will be looking? Kind of changes how we define it, but the general idea of it being a relation that for every input, there is exactly one output, and it must be predictable. That won't change. But how we officially define it, it's going to change book by book and apparently paragraph by paragraph, even, just depending on what we're looking at. Okay. Any questions? Okay. So I gave you an example. And in this one, I loved how many people were trying to make them make sense. I kind of made them make sense, and then I kind of didn't. So it wasn't really about making sense. It's more about what button are you pushing and what happens. So in this case, you hit frog, you get hop. You hit lizard, you get crawl. Oh, come on, there we go. You hit toad, you get hop. Wait. I'm hitting lizard again. Okay. So I'm going back. I'm hitting lizard more than once. The first time I got crawl. The second time I got slither. Therefore, no, this is not a function, because if I input lizard, I don't know if I'm going to get out crawl or slither. Now, for all of you doubters that were like, lizards don't slither, there is such a thing as a legless lizard. So just keep that in mind. My son is way into zoos. Has been his whole life. I have been to more zoos than you can imagine. I'm way into animals. I know, it's not. It's a legless lizard. It's not a snake. I don't know exactly. I've never really quite figured that one out, but it is true. Yeah, way into animals, made me way into animals. I bet nobody else here has been to the Rome Zoo. Yeah, in Rome, we went to the zoo. He was like on strike. He was like, we haven't been to a zoo in 10 days. I'm not going anywhere else. My daughter was so mad. Anyway, yeah, I've been to zoos all over the world because that's what my son likes. All right, so I love animals. You'll get a lot of animal examples in here. Okay, now I don't think anybody in here, maybe one person, no, I don't think anybody in here took the quiz when it was like this. I screwed up. And Jameson finally pointed it out. So I'm going to fix it. The one you took had a little difference, and that was that little negative was gone right there. There was no negative there. So I kept it there just in case you looked at it and were like, I can't figure out why I got it wrong. Anyway, so there's that. I don't want it to be white anymore. Okay, so which of these is a function? So now we've got order pairs. It's another way of looking at it, right? X is your input, Y or F of X or G of X or whatever is your output. So we're looking for every input X. Is there a unique output Y? So my inputs here are -3, -1, 0, and 4. Well, they're all different. So there's no chance that it's not a function because I'm never hitting the same button twice. So that limited amount of information I have means that yes, this one's a function, okay? But let's double check the others. A lot of people didn't realize in the formative, a lot of times I'll put things that multiple things are the correct answer. And that's where you can actually select that. In this case, you couldn't, but let's double check. In this case, I notice there are 2 inputs of -2. And the one, the output is -2. The other, the output is 2. This is not a function. I input -2. I might get -2. I might get 2. That's no good. Okay. In this one, same thing. I click -3. Now, as I had it set up, if these were both -3, that's fine. I can hit -3 and get -3 out all day. That's still a function. It's predictable. But in this case, -3 gave me -3 and -3 gave me +3, not a function. Okay. Getting me to the last question was then, okay, here it is. How do we write the domain and range? Oh, went too high. So the way we're doing this, in this case, it's a list. And we're going to look at more ways to write set notation, all different ways to write things. It's not going to be kind of one set way as we move. Kind of depends on what it is we're reporting out on. But in this case, what is the domain? Now, always, I hate using that word always. Let's assume most of the time. Let's just go with always, but always in this class needs to be taken with like little parentheses, little quotations, because every time I say always, we're going to find an exception. But it's always good idea to communicate well by saying what it is you are writing, okay? So I would always start by saying the domain. You will see on my work, we can do in this class just a D. You can assume if there's a D that what we're referring to is the domain, because domain is such a common thing. D and then a colon means what you are about to read is the domain of the function, okay? So either write the word domain out or use a colon. Both are fine. Then we're going to be using set notation, okay? In this case of a list. Set notation of a list is always going to consist of these little curly cues, and we're going to get really good at them. It's kind of the best way I know to teach people to write them is it's like a little weird S and then the other way, and then a backwards S. And then the other way, it's the backwards S and then the little S. That's the way that you can write these. It's a little tricky, but we'll get good at it because we're going to write these a lot. So the domain is a list in this case because it's just a series of numbers. We always write them. It's good math manners. It's not wrong, but it's good math manners. We don't want to be rude to write numerical lists in order from small to large. And I happen to do it that way here. But even if the points are not in that order, you should always write it from small to large. Each thing separated by a comma. And for formatting purposes, if you really want to see that green light, always put a space after the comma as you're typing it in. So -3, -1, 0, and 4. That is my domain, my list, and my stylus and I aren't getting along very well today. My list of things in the domain, there's only 4 numbers. Now, I had people that said the interval from -3, geez Louise, come on, stylus, to 4. That was a common thing, the answer I got. Not true. You need to think about the fact that not every answer is included. This is a list. We cannot assume that 1 is part of our function, is part of our domain. We cannot make that assumption. And we'll look at things where we are looking at intervals next class, but we can't assume anything other than the information we were given. So it's just those 4 numbers and only those 4 numbers. Okay. For the range, there's only 2 numbers, -3 and 2, and it repeats itself. When we are writing the range, again, we're going to make a list. Don't repeat things. That just adds confusion. There's only 2 numbers, only 2 outputs, even though we don't have them, they're repeating themselves. When we write domain and range, we're not giving that relationship. That relationship is expressed in that list of ordered pairs. So you're just going to do the ones that are there, -3 and 2, and that's it. Okay, I should put these little commas. That's for the set notation of a list. And we will be dealing with set notation of other things on next class or Monday for you guys. All right, stopping the share. Oh, it's not what I meant to do. I'm going to stop the recording